Happy July 4th, everyone! I'm Brittany, a science interpreter here at the Franklin Institute. And what other way could we celebrate the 4th of July than with fireworks? So I want to talk about the science behind all of these fun things that we're going to be doing this week. This is a sparkler. You've probably seen it before. It's coated with a type of fuel, one of the 3 ingredients needed in combustion. And that fuel is actually a type of metal salt. Looks a little bit like this. Not the salt that you put on your French fries, although somewhat similar. We have different kinds of salts that are made up of different atoms. Those atoms, when they're heated up, they speed up and they emit a certain color on the spectrum. So when you see your colorful fireworks lighting up the night sky, let's decode where those colors come from. So for our heat, we're going to use my blowtorch. Our fuel, again, is going to be a salt solution spray, and the oxidizer is going to be found in the oxygen all around us. So if you would like a lovely, bright pink firework, all you need to do is add a little bit of lithium. So when you see that firework that's pink, you have to yell out, lithium! So let's try something else. This one's actually one of my favorites. Now think about a metal that you might know of that when it gets in touch with an oxidizer or the air around us might turn green. Did you say copper? You nailed it. Copper causes a green flame, just like the Statue of Liberty got green after being oxidized. And last but not least, one of our brightest reactions for the smallest amount of salt is our strontium. The only use that I can think of for strontium, it's an explosive, and I think we use it pretty appropriately. So these metal salts added inside of those firework shells, when they go flying into the air and burst, they will give you all those magnificent colors. And for some reason, my boss won't let me blow up a real firework in here. So we've got the next best thing. Not a firework, but balloons. Now, what do we normally fill balloons with? Helium. But there's actually a worldwide helium shortage right now, and helium has a property that's called inert. That means it does not react with fire very well and is science for boring. So we're using another gas that's a little more exciting. It causes an exothermic reaction, and it is also lighter than air and very flammable. Did you say hydrogen? Man, you guys are on a roll today. Hydrogen is a very combustible gas. And not only did I put hydrogen in these balloons, but there's also some of those metal salts inside. And those metal salts add the color. So this is what you're going to see thousands of feet in the air to celebrate our country's birth. Now, we all know fireworks can be very dangerous, so safety first. And it wouldn't be a very good idea to just go up to the balloon with a small match. So instead, we're going to use an original Franklin Institute invented tool called the Proximity Enhancement Device. It's really just a candle on a stick. And I'm going to stay as far away from that flame as I can. So each one is going to set off a chain reaction, and pay attention to the color of those flames. Do not try this at home, your home, or any other home. Here we go. 3, 2, 1. And we've got one more left, the red of the mighty American flag. Let's see what we have. Ooh, lovely. So we had multiple different colored reactions in those hydrogen balloons. Inside of the blue balloon, we had a very bright reaction caused by strontium salt. It kind of overshadowed our small white balloon with copper salt. And my favorite, that red balloon was filled with not one, but 2 salts. We had magnesium, which was our sparkly white salt, in addition to lavender, which was caused by potassium nitrate. Do you know where you can find potassium in our everyday world? Bananas! You're so right, but hey, do not go lighting your bananas on fire. You will not see that awesome reaction. Happy July 4th, everybody!